Here we are looking at example 7 from our 2.4 number 1 set of notes. We're asked to write the equation of the line that's perpendicular to this line and passes through this other point 2, 1. So graphically, what's going on here? If we just have this xy coordinate plane, we'll just say that this is our red function. So we have -3 as the y-intercept. And from that y-intercept, we are going up to over 5. We should see a line doing at least something like this. Now we're trying to write the equation of a line that is perpendicular with this line. And it has to pass through 2, 1. So at this point we have 2, 1. And we're trying to figure out what is the equation that is perpendicular with this red line and passing through that point, creating again that 90 degrees if they are in fact perpendicular. Well, using this line, y is equal to 2/5 x minus 3, we know that the only thing that we're going to go ahead and use from this is the slope. And we're going to try and find the slope that's perpendicular to this slope. So we have m is equal to 2/5. That's what we're going to use. And we want to find the the perpendicular of this slope. Now, perpendicular again is opposite reciprocal. Okay, so that's going to come in handy. So we have 2/5 as our slope. We first have to take the opposite. So the opposite of 2/5 comes out to be -2/5. Just pretty much take the opposite sign. Now comes in the reciprocal, and that's pretty much where you just flip these two numbers. So we end up then with negative still. Now flipping these numbers, we end up with 5/2. So this is in fact what our slope that we're going to go ahead and use. So this is the m we're going to use. Even from our diagram, we can see that it is in fact going down at about a rate of -5/2, so down 5/2. Now, we also know that it has to pass through that point, 2, 1. Well, from here we can go ahead and use our point slope. Y minus y1 is equal to m times x minus x1. And again, we already know our x1 and y1. That came out to be, from our given, 2, 1. So pretty much just going ahead and substituting in what we know. We have this arbitrary y first. Minus our y1. Here is our y1, 1. Equals our m, here is our m, -5/2, times x, again this arbitrary x, minus our x1, here again is our x1, 2. Going ahead and distributing our right side, we end up with y minus 1 still on the left, equals -5/2 x. Negative times negative is a positive. 5/2 times 2, well, ultimately when you distribute that 5/2 in, the 2's would cancel out with one another because one's on top, one would be on top, one would be on bottom. You could also multiply the tops and end up with 10/2, but you still end up with 5 in the end. Lastly, we're just going to put this into y equals mx plus b by adding this 1 over. We end up with y is equal to -5/2 x plus 6. So now that we have things in y equals mx plus b, let's go ahead and convert this into standard form. In other words, we want those we want those x's and y's all on the same side. So we're going to go ahead and add this 5/2 x to both sides. And once we do that, on the right side they cancel. On the left, we have 5 halves x plus y. Again, y was positive, equals 6. But again, as always, we can never have a fraction in any part of our standard form. Here we see that fraction. And in order to get rid of this 2 on the bottom, we'd have to multiply both sides by 2. Then when we distribute that guy in, we end up with 10 over 2, which is 5, coming from right here. 2 times y is just 2y, equals 12. And here again is our standard form where we see all the x's and y's on the same side equals some number. Notice too, none of these are fractions. Likewise, this first guy, x, is not a negative. So again, though, that is example 7 from our 2.4 number 1 set of notes.